I'm, yep, okay, got it. Thank you. So I'm Dr. Amy Frame, and today we're going to talk about the mechanical engineering and mechanical engineering technology programs that are housed in the Mechanical and Materials Engineering Department, and hopefully give you a better idea of what these are and what the differences are, so you can make, your decision on what major might fit best for you. So a little bit about me. I am a 20+ year Bearcat at this point. So started here in the 90s as an undergrad first, and then did get my PhD from here. So a few fun pictures. I still do a lot of alumni bands events because I did march when I was an undergrad. And then one of the pictures on the bottom of the screen is me on the last student trip that I went. So I took a set of students to Germany over spring break. That's attached to one of the classes taught as a elective in the College of Engineering. So that was a fun trip. Hopefully, when the COVID dies down, we'll be able to get back to things like that. So a little bit about me and what I do here. My email is up on the screen and it is at the end as well. So if you do have any questions that don't get answered today, or in a couple of days you have something, I'm always willing to answer questions. Email is definitely the best way to get a hold of me. Okay. So first, before we get into the differences between the two majors, just a little overview of what mechanical systems are, because these are the systems that both majors are going to work on. So when we think mechanical systems, often, it is basically anything that moves and doesn't fly, although we work on pieces of aircraft. So anything that moves is going to do some kind of work. So if you see the pictures there, it could be anything from automobiles, planes, down to just gears and bearings, HVAC systems, lots of different types of moving parts and things. We typically get, a lot of people hear that we are some of the broadest and oldest. I argue that there's a set of engineering that are fairly broad. We just use different math. So, and I'll show you kind of what broad means here in the next few slides in pictures, because I think that helps explain what broad in the sense of mechanical engineering means, right? And we'll learn about a lot of different things that you can do with this degree and where our students go in both degrees, and kind of what you can do with these degrees, and what kind of career opportunities you would have. So like I say, what does broad mean, right? So one big area of mechanical systems, whether it's technology or engineering, is what we dub like structural dynamics. So if you want to think of what you see on the upper right hand picture there, is kind of your struts and shock system on your car. So what keeps you from bouncing around when you go over a bump. All these pictures that you see are either from textbooks we use, or actual labs in students of ours. So we do have a big lab here in the high bay where we can literally shake cars or other things to verify that our models are correct and see how they behave. So this is one big thing. I think this is one that's easy for students to kind of picture, because it's like roller coasters and a whole bunch of other structural things. And it's some of that physics that you may have learned or will be learning. And this, come on. Robotics is a big draw, right? A lot of students come in with robotics. When we're talking robotics from mechanical point of view, it's going to be mostly the linkage systems, the motors, the if you see here, the arm, right? Some of our students might get a CEAS minor or certificate because they want the programming part of that too. But the programming part sometimes is, these are groups of students that are from various majors, and the mechanical engineering students are going to work mostly on the moving actual pieces parts to this, right? And the ones on the right here are from a cool co-op from one of our students that worked for a government lab. So once they got declassified, she was able to share them. Big part that some people don't think about is heating and cooling and thermal power, fluid power. So your refrigerator, Here, Caterpillar and a lot of heavy machinery. So this is one of our fluids labs. How do you use hydraulics, jet engines, turbo engines, and that does lead us to also power and energy, so nuclear or wind farms. So you see now, like in Ohio, you see all of the wind turbines that are generating power for us. So if you want to get into renewable energy, often we're into that realm, those kinds of things for renewable as mechanical. And again, kind of down here is just a little bit of the math and stuff, if you're wondering why you have to take calculus or physics. If you notice, physics is a big part of what you're going to see as far as science-wise for the mechanical systems. And then we do get into modeling and simulation, not necessarily the coding, because again, that's going to be more computer science, but you have to know what you're getting out of that computer code makes sense or is right. So that's often where mechanical engineers come into play. If you want to think about using your calculator, if you put in 2 plus 3, you have to know that 6 is wrong, right? That you accidentally pressed multiply, not plus. So same thing goes with these like really big systems like ANSYS. Like, does that answer come, right, make engineering sense? And if not, why? What might be wrong in the code? What do you have to correct? So we do get students that work for those kinds of companies doing that work. And then we get a lot that are in manufacturing. So we have additive up here, right? Fancy word for 3D printing, both in metals and plastics, plant layout type things. This was a project that one of our MAT students did on co-op, saved the company lots of money. So we still do get in a lot of how do we manufacture, how do we make things? And I think this is where we get in broad in this respect that we're in a lot of companies, because every company needs to have their product made, right? And so how do you make those products? And so a lot of the companies our students work for are not consumer companies where you would know their names. They're going to be what we call tier 1 or tier 2 companies, where they make products that they sell to a Toyota or a Coca-Cola to make their parts, right? Or make their products. So that's kind of in pictures what mechanical systems are. I know what you guys are here for is what is the difference between engineering and engineering technology. So I'm going to start getting into those differences now that we have a general sense of what mechanical systems are. And again, we're going to use math and physics in both of these majors to describe these types of systems. So that's the basic framework we're using. How we use it is different. So engineers are going to use a lot more higher level calculus and do a lot more analysis, theoretical work. It's a little bit more abstract. Some of the courses are taught a little bit more abstractly or full-fledged modeling, because that's the way we're going to approach things in that major. In technology, the way we approach things is more application-based. Still can use calculus, some of the lower level calculus, definitely physics. But we have this theory, how do we apply it to mechanical systems? How do we get a design or a product result with these known applications, known theories, known principles? So that's the overarching big difference between the two. So what does this really mean in practice? So with that, right, emphasis again. And for all of these slides, left-hand column is always going to be mechanical engineering. Right-hand column is always going to be mechanical engineering technology. So we can kind of do a side-by-side comparison. So again, the focus for engineering majors are to develop new, potentially things. So fundamental theories, abstract concepts are the emphasis of the program, whereas technology is implement solutions potentially quickly, especially in a manufacturing environment. You know, the more time that a line is down, the more money that's costing that company. So it may not have to be the most efficient solution, they just want a solution. And so there's established methods to do that, to come up with those. And so how do we apply them, you know, to engineering problems? Curriculum-wise, then, this shows up in coursework for the engineers. That is a lot more. We're going to model systems, we're going to analyze them, we're going to look at them from a theoretical, maybe three-dimensional point of view. whereas the technology curriculums is less abstract. Right? We're going to often simplify, if we can, to algebra or trig or Calc 1 type topics, and really stressing application and implementation of these concepts and how do we do that. And so this can be kind of hard to kind of wrap your head around because there's still design and there's still, math and engineering involved in technology. Some things to easily wrap your head around is mechanical and aero are often very similar. So, but with aerospace versus mechanical, in mechanical, we're simplifying that gravity is constant and mass is constant. So we can use F equals ma. Whereas aerospace actually can't make those simplifying assumptions because a mass of an airplane changes drastically because fuel is their heaviest thing. And same with gravity, as you get up into space, gravity changes. So, right, even aerospace through versus mechanical makes simplifying assumptions because we're close to the ground and cars typically, right, or our machines that we're making don't change their mass very much. So it's the same thing with mechanical and mechanical technology. A lot of things can be two-dimensional. Bridges actually can be designed two-dimensionally for the most part, a lot of those things. So there's a lot of things that can be simplified down that don't need the full-blown 3 dimensions or a lot of the extra calculus to be described well. So that's kind of where that difference is and where there's still engineering, still some analysis, but is definitely less abstract than what engineering may get. So where this transfers after graduation, right? So in the workplace, some titles that our students get right out, right from graduation. Mechanical does vary pretty drastically, but a lot of them will be design, testing. They'll still get into manufacturing. You'll see a lot machinery design, automotive design, design of products, so other products. They'll get into technical sales often, be that bridge between the engineers and the company they're selling to. So technical sales is not necessarily consumers. Again, they're going to go into, say, Coca-Cola and see what Coca-Cola's problem is and say, hey, we have a machine or a robot or something that can solve that problem for you so you can get, more pop in the cans quicker, right? Kind of thing. Technology students will generally, off the bat, will be hired by manufacturing companies, construction companies, more fabrication plants, product, packaging companies, that kind of thing. Again, sometimes more in the field, you see some of that, some production planning, because some of their curriculum is a little bit more geared towards manufacturing in some ways. Doesn't mean they all go into manufacturing. There's definitely some differences there, especially with the co-op experience. Some of them will start into design and other things like that. So that's kind of short term. Long term, both will end up in management positions, and this, I know, might not help with your decision making long term if you want to be management or professional engineers or some of these that cross borders. Then I would say, how are you going to learn best? Are you going to learn best with abstract concepts or more concrete concepts? Our technology students, because they take a little more statistics and a little bit more production planning and control type stuff, will tend to move into the quality and inspection and quality control type areas a little more often than our engineers. Engineers, if grad school is the thing that you definitely want to do, grad school being a master's of science or a PhD. MBA is both, and there's some, again, crossover there. But if you definitely want to kind of work for NASA or Los Alamos Research Lab or even Wright Pat in Dayton, those engineers typically have their master's of science or PhD. So that would be something that a mechanical engineering degree is going to do for you, because you're doing the theoretical stuff in your undergrad. You're better set up for research. And then if you go to grad school, that's where we become, like, I'm a professor here at UC, or a lot of the people that I went to grad school with are at national labs, or other corporate research facilities. So those are the long-term career things that can happen with both degrees. Curriculum-wise, how this shows up, first year is and so this is the first year. Again, columns, ME is on the left and MET is on the right, and each semester is the same. So kind of just showing here quickly, I'm not going to kind of go in detail unless there are questions about curriculum. But both will take calculus in the first year. First semester is pretty common, but as you see, it starts to branch out where the calculus-based physics and sciences versus the algebra-based. And again, MET's Calc 1 is about the limit of math that they take. So you won't see much more calculus in their degree plan. Again, because it's not necessary. Then when we're talking labs, you can see where, okay, there's some similarly titled courses like manufacturing, but you see on the MET side, they have that manufacturing and they also have a lab that goes with it so that they can kind of see in action what they're learning in the classroom. Same down here with something a little more abstract like strengths and materials. Strengths, materials, solid mechanics, similar topics. But again, this is going to come at that theory-based. This has a laboratory, again, with that more, how do we apply these principles, seeing them in action? There's a little bit more calculus, mini calculus down here as you get farther in the program to help with the later half. And that's later in the semester. Again, because they don't need as much higher level calculus like the diff-EQ and multivariable you see in ME. And then this is your middle years. They're all kind of, you can see where it kind of branches out into some of these modeling and controls classes. So a lot more abstract, whereas then technology gets into a little bit of motion control is like robotic control, or how do we path plan some of these things, product development, how do you, figure out how we're going to manufacture parts a little bit. So a little bit more into that industrial area. Manufacturing area of stuff. And then senior year is pretty open for both majors. There's a lot of electives on here. So it doesn't look like a lot of classes. It's actually 15 credit hours every term for both majors. And then we help you with those electives later on. So again, kind of wrapping up, I'm leaving a lot open for questions. So that way, I can answer what you guys have questions wise. We have both programs. Mechanical engineering is that more abstract theoretical program. There's definitely, if you want that master's of science that then leads into a PhD, that's one of the big things, differences that they're typically going to set you up a lot better for that. Technology is more application based. Definitely gets a little bit more into the industrial manufacturing areas, manufacturing plants. How do we make things, right? It's great to design some things, but if you can't actually make them, it doesn't matter. So that's the areas that they'll get into more, right, as programs go. And like I said, I wanted to leave plenty of space for questions. I can always go back to slides if you have them. My information is right here on the screen for you. That is not me. That is actually one of my partners in crime. I'm actually in that picture, but well, I'm in the room when this happened. But really, don't fear failure. This was just taken 3 years ago when Professor Maines and myself were learning how to use that piece of equipment you see behind you. And we did not do well, and if you can see, there is a pool of oil on the floor because the valve came loose and shot oil all across the room and drenched us both. We learned a lot that day. We also failed a lot that day. But that's part of engineering, right? And trying to figure things out. So I know I kind of like the quote from Einstein. And yeah, with that, I guess I'll open it up to questions for whoever's here. No questions? I answered all of your questions.
I mean, I will ask a question.
Yeah, that's fine. You can too. Yeah. If I miss something.
No, I don't think you missed anything at all. I think a lot of students, like basically what I want to ask is if a student is in one major, but they want to get a little exposure, like if they're an MET, but they're hoping to get experience in design, like how are the companies that students co-op with very different? Or can they kind of like, how can they kind of cross those barriers, if at all, during the co-op search? Can you just speak to that a bit?
Yeah. So some of that is student dependent on their strengths, but there is there's definitely crossover in some companies, and actually probably in at least half the companies, I would say, um, of ME versus MET, of getting design experience. What that design experience looks like will vary by company. Because GE is a bigger company like GE, you might see a smaller aspect of design because it's broken down a little bit more. A smaller startup, you might see a larger part of that process. So some of that can be company based. There's definitely, though, some of our METs that have been able to try design and manufacturing and kind of see what fits better for them as well. And they get treated at that company like an engineer, just like a mechanical would. And so, yes, and that's what makes, I think, this hard choosing the major, because there is an overlap in what both majors can do out in industry. There's definitely industries that want a mix of both or don't care which one they have because you have enough background with either major. So then if those are the kind of careers you're hoping to go for, then looking at the way you learn is a good deciding factor, right? Where you're going to have that better fit of learning style. Does that help answer that question?
Yeah, that was awesome. Thank you.
No problem. And I get this is a hard distinction to make, right? What other questions do you all have for me?
If there are no other questions, we can go ahead and call it a wrap for the day.
Okay. I said I always have in my back pocket. Yeah, I always have a back pocket for quiet times.
Oh, this is cool. Yeah, please.
Yeah. So yeah, maybe this will jog some questions, maybe not. And this is independent of what major you ultimately choose. But some advice I just have, and these are all different things across UC, right? There's a lot of stuff at UC to get involved in. I was not involved in anything engineering related as an undergrad. You don't have to be, or you can be. I have friends that were only engineering stuff, but get involved, take advantage of stuff, minor certificates, research, travel. I wish I traveled more as an undergrad. It's harder to do now that I have a full-time job. And then biggest thing, time management. You have time to get involved and do these things, but you can't sleep until noon and then do this. So managing your time, figuring out where to put your effort, utilizing, we are here to help you, right? Utilize my office hours, right? If I have you in class, right? And that's our most successful students figure that out early, right? They go get the help they need early and often. Whether that's in your freshman year with Learning Commons and like the Mass Center and some of those things, as you get up in your later times, professor office hours are going to be the best thing because we all start teaching those specialized classes. So there's not a lot of tutoring that's available because they're so specific to your major, right? Your academic advisors, peer tutors, all those things, CAPS, right? Get help. We're here. You're paying for it. You might as well get the most out of it. So that's always my advice in general. Like I said, I've been a Bearcat for 20 plus years. So if you don't have questions about this and have questions about something else, I'm willing to answer that as well. Or we can just call it, like Corinne said, either or.
I have a question.
Okay.
All right. So let's say I'm a recent transfer student. So how can I be more involved in the MET program? since I was in my previous colleges.
So what were you involved in? Like, what kind of groups were you involved in your previous college? Was it just like an MET general group, or was there like something specific to it?
It was a MET major, so it was an honest major in both colleges.
Okay, because and we're pretty big, so like MET students, there's a several groups they'll get involved in. So we have BattleBots Club, we have yeah, thanks Corinne for the organizations, but you can look at BattleBots, a lot of the car clubs. So we have Formula Car, we have BUV, we have Baja, Solar Car. I'm probably missing a car one. I hate cars, so I don't think about them. No, it's mechanical cars are a great engineering system. And so there's a lot of that gets involved. Robotics Club. So those are the big ones that a lot of METs will get involved in, and ways to meet students in MET. Engineering Tribunal is also that's kind of the general student government body for the college. That's a great way to start getting involved and seeing what's out there. And then there's all the professional organizations like ASME, or you have at NSBE, or the Society of Women Engineering. You don't have to be female to be part of that organization, right? So there's some of those other organizations as well to meet people and get involved. So it kind of depends on what your interest is. If I were to do that one personally, I'd probably pick robotics, because that's, what my interest would be. Oh, and TEA. Some people don't know what that is, but that's a Theme Park Entertainment Association. And that's actually across the university. You get to meet people from like CCM and DAP in engineering. It's an amazing group too. But they advertise, and it looks like it says T, but because it is an abbreviation to TEA. That's another a big group that a lot of students get interested in. Does that help? Because we don't have just like here's MET student group kind of thing.
Yeah, that kind of helps. I was just also curious because I took multiple classes in my previous schools, and those were transferred in here, but I guess there's some kind of complications, so I don't honestly know.
I mean, and we can always talk offline about your transfer credit and stuff if you wanted to, right? Or Corinne can help probably with that as well.
Yeah, I'll put an email address in the chat box. And what I would just have you do is send us a question, and I'll connect with your advisor, and we can kind of look at what's going on with some of that credit. We'd be happy to dig into that for you.
Okay, thank you.
Of course.
Good question.
I don't have any questions, but thank you guys.
No problem. And again, if you come up with ones, I know Corinne put her email in the chat. Mine's up on the screen, right? So if you come up with something else later, that's fine too. Okay.
Yep, thanks.
No
Okay.
problem. So I guess, Corinne, that seems to be it.
Yeah, that was
Sweet
wonderful.
day, I guess. No problem.
Thank you so much.
No
I'll go
problem.
ahead and cut the recording. And